All right, Physics 3030, the Universe, Lecture 3. This is the second lecture about astronomy. And we are going to continue our discussion of how we measure the distance to different stars out there and different objects. And we'll be talking about the inverse squared law, which covers a lot of different laws in physics. And we'll use that in conjunction with something called luminosity distance to measure how far away these things we call standard candles are. And standard candles are just special stars, special types of stars that we know the properties of that allow us to measure how far away they are. And then we'll get to electromagnetic spectra as we keep moving along here. So let's close that ink layer and move to a clear page. Let's see what we get here. So we're going to start talking about inverse square laws. We talked a little bit in the last lecture about when something is inverse, you get with the properties that you get as something goes up, something else goes down. And for these laws, there's an easier way, I think, to think about it, at least to start with. And these all have to do with something that either has a spherical source. And this also works for something that is a point source, but this is just a point source is really just a physics toy about the way we think about things, just starting in a tiny little point. But really, most stars out there can be thought of as spherical sources, okay? And there are other things besides sources of light, like stars, but let me just start drawing a picture here. I think this will make it a little bit easier. So I have some ball that's a source for something. And in our case, we're really going to be thinking about light. Okay, so let's think about light emanating from this thing sort of in all directions, right? As a sphere of light coming out of it. Okay. Well, as that light expands and comes away, it actually gets some part of it spread. So not some part of it. It all spreads out as it goes, right? So at any given instant, say there's some type of explosion or something like that, okay, then it's described by this big sphere, okay? And this could be the wavefront of a sound wave that started at a point. This could be a supernova explosion, or it could just be the normal light that's coming off of something. It doesn't have to be some specific event. But as it comes, it spreads out. And the area of this thing is the surface area of a sphere, right? Which is, so the surface area of a sphere is 4 pi times r squared. Okay, where r, right, is